No, taking my son to the LAX. All right, solving exponential equations. Again, review from Math 3. When we have this, as easy as it is to do in our head, we want to know how to show the work so when they get harder. And how do we show the work? Getting the bases the same. 2 to the x equals 2 to the 5th, x equals 5. In order to drop the bases, what two things have to happen? The bases have to be the same, and there has to be exactly how many on each side? 1 on each side of the equal sign. We'll learn how to address it when they're not the same or when there's more than 1 on each side another day. All right, number 2. 8 to the x equals 32. Definitely not one that's as easy to do in your head. Do you agree 8 to no whole number is going to give me 32? 8 squared is what? 64. So there's no way that's going to be a whole number. So am I going to change one side or both sides? Both sides, because there's no way to get 32 to a base of 8. So I'm going to change them both to what base? 2. I'm going to put parentheses here with the x. And then here, 2 to what power? We just did this one. 2 to what power is 32? 5. 2 to what power is 8? And then you learned this last year and the year before. What do you do with the power to a power?
Multiply.
So it's 2 to the... All right, so what did I say? Once you get down to exactly 2 bases on each side, and they are the same, what can you do with the bases? Drop them and set the exponents equal. So what's our new equation? And divide both sides, get your fraction. What does x equal? 5/3. I would definitely expect work on this type of problem. And remember, when you're doing homework, you write the original problem. On something like this, you'd write the original problem. You could skip that step if you'd like and just give me x equals 5. On this one, I definitely expect to see work. All right, number 3. 5 to the x equals 1 over 25. Good job. How many of you can look at it and already tell what the answer is without any work? What is it? -2, because 5 squared is 25. 5 to the negative second, 1 over 25. Again, one on the work, on your homework, that I would expect you to write the answer, and then giving me no work in the, write the original problem, and then the answer without work. And I'm okay with that, but we're going to show our work in notes. 5 to the x equals 5 to what power? 2. Drop the bases, x equals -2. So even when they're that easy in homework, do you still have to write the original problem?
Yes.
Yes. All right, number 4. 1/2 to the x equals 64. All right, a little harder. And I would want to see some work here. Can you tell what the base is going to be? What base we're going to use? I hear one person whisper a number. 2? Are you guys okay with using 2? Is anybody thinking 1/2? Either one, base of 1/2, a base of 2. Which one would you guys like me to use? Either one's going to require some negative exponents. Base of 1/2? Yeah. Yep. So 1/2 to the x equals 1/2 to what power? Oh, thank you. 1/2, and I said x, didn't I? This is typically not the way I would do it. My brain doesn't process it this way, but totally okay if you do. Do you want me to continue this way? I hear some of you guys saying no. No? Okay. It's okay. There's nothing wrong with it. Again, that's just not how my brain processes changing this to a 2. 2 to what power is 64? 2 to the 5th is 32, so 2 to the what? 6th. And then I want this to be a 2, so 2 to what power? I know it's going to be something to the x negative 1. Is 2 to the negative 1 equivalent to 1/2?
Yes.
Yes, and what do we do with the exponents?
Multiply.
2 to the negative x equals 2 to the 6. Exactly one base on each side? And are they the same? Can we drop them and set the exponents equal? Negative x equals 6. Divide, what does x equal? Negative 6. Questions? We're good? All right, number 5. Eight to the 4x minus 1 equals 1/2. I'm going to let you guys try this one on your own, just to see if you've had enough practice. What base would you guys suggest? 2. So that means the right side, are you going to need to use a negative exponent? All right, go ahead and try it. All right, still working? Any answers? 1/6. Anyone else? Same or different? Same. All right, so what did you guys change the 8 to? And what did you do with the 3 and the 4x minus 1? Multiply, which means you have to distribute. So 2 to the minus 3. And this was 2 to what power? And then is at this point that we can drop?
Yeah.
12x minus 3 equals negative 1. And I'm assuming you guys solved that on your own. You added and divided, and what did you get when you reduced everything? Yes, you added the 3. Got 2. 2 divided by 12, 1/6. Are we good? All right, number 6. 27 to the x equals 9 to the 4x plus 1 over 3 to the x. Oh. All right, there's multiple things going on here. First, what did I say? How many bases can I have on each side? So what are we definitely going to have to do here eventually? Okay, I could multiply this to the other side. Or can I change them to the same base and subtract the exponents? Yeah? All right, same base. So 27, I want to get to the same base as well. What base am I going to use? 3. So 3 to what power? Raised to the x, which gives me 3 to the, all right, equals, and then 9 is going to become 3 to what power? 3 to the second raised to the 4x plus 1 over 3 to the x. So far, so good? All right, 3, I'm going to write this down again. 3 to the 3x equals, what's that math word you guys gave me earlier? Distribute. 3 to the 8x plus 2. All right, so before I drop the bases, I need 1 on each side, and this side I have 2. So what do I do with the exponents? Subtract them. So I have 8x plus 2, take away x. That's what you're processing in your head. 8x plus 2 take away x. 3 to the 3x equals 3 to the what power? Does everyone agree like terms are here and here, so 7x plus 2? Okay, before I go any further, questions? All right, what's the next step? Okay, so now I can drop the bases, and I'm moving this way because I am running out of room. So 3x equals what? 7x plus 2. And again, I'm allowed to drop because the bases are the? And there's exactly how many on each side?
1 and 1.
1 on each side. I cannot have more than 1 in order to drop the bases. All right, go ahead and solve. Subtract your 7x, divide your 2. Divide your negative 4, sorry. I know. All right, divide your negative 4. What's your final answer? Negative 1/2, thank you. Okay, questions before I move on? We're good? All right, I'm going to do another one like this where there's multiple bases just to make sure we have a handle on it. Number 7, 1/2 raised to the negative x plus 3 equals 8 parentheses 2 to the x minus 1 raised to the 4th. When you guys had them like this last year, were they ever this complicated?
No.
No?
Definitely not.
Okay. All right, but we can handle it. Any suggestions, thoughts on this problem? Change everything to a base of 2.
Yep.
All right, so 1/2 is going to become 2 to the, and then negative x plus 3, I'll distribute later. 8 is going to become what? 2 to the 3rd, and what am I going to do here? Multiply the 4 to that, so what's the math word again? So times 2 to the 4x minus 4. All right, this becomes 2 to the positive x minus 3. Yes or no? Now, if I wrote this down right here, would I be able to drop the bases? Why am I not ready to drop the bases?
There's no 1 on each side.
Exactly 1 on each side, and which side is not following the rules?
Right side.
The right side. So what do we have to do here? Good. Earlier on the page before I subtracted because it was a fraction, because I was dividing, but now that I'm multiplying, what do we do? Add. 3 plus 4x minus 4, combine the like terms. 2 to what power? 4x minus 1. Now what can we do? Now can we drop the bases? Why? Because they're exactly the same, and exactly how many on each side? 1. Drop the bases. X minus 3 equals 4x minus 1. I'm going to let you guys move your x's, divide, and get your answer. It does come out to be a negative fraction. A question on anything before, on any one of these steps? Yes. Why don't I multiply the 3 to this? A good question. When do we multiply and when do we add? When it's something like this,
Same base. Then if it's different bases with the same exponents, we multiply.
yeah, so when it's like this, you multiply 2 to the 3x. If it's something like this, you add, and it's 2 to the x plus 3. Yeah, so when it's a power to a power, that's when we multiply or distribute if it was like x plus 1. And when it's like this, we just, so let's actually make this an x plus 1, then we would distribute. And then we would have x plus 4. Do you see the difference? Okay. All right. So anybody have the answer? What did you get? Negative what? Questions? All right. What if you end up with something like this, number 8? 3/4 to the x equals 1 7/9, which is something you will end up with. Any thoughts? I'll give you a chance to look at it and stop messing with your phones. Can't breathe. Okay, thoughts? Okay, she said, would you make the right side an improper fraction? Anyone else have that same thought? All right, so 3/4 to the x equals 9, and then you multiply and add, what do you get? 16/9. Okay, take a look at the fractions and how they are related. There's a 3 and a 4 and a 16 and a 9. Can anybody see any relationship? Okay, I saw some cross. What's 3 squared?
9.
What's 4 squared? Okay, so can I get them down to the same base? Yeah, what are the two same bases going to be? 3 and 4. But what else am I going to have to do as I shrink this one down to the same base?
You have to square the last. Oh, you're negatives.
One of them is going to be negative. I'm either going to flip this to a 4/3 or flip this to the 9/16. Do you agree? All right. I have to square this one or change it to the bases, the like bases. So do you want to flip this one since I'm changing this one anyway?
Yeah.
All right. So I'm going to do two things at one time. I'm going to flip it and change it. Does that make sense? All right. Actually, I won't go so fast so I don't confuse anybody. I'm going to first do this. And why am I doing this? So the 3 matches with the 9 and the 4 matches with the 16. Now I'm going to get them to the same base. And what's the same base going to be? So 3/4 raised to what power? Squared, and with that negative 1 is going to be a what? All right, it looks like I maybe went too fast there.
I'm confused with the exponent.
Okay, let me take a step back. All right, 3/4 squared raised to the negative 1. All right, I'm just going to cover the negative 1 for now because I'm not doing anything with that. Do you guys agree that 3 squared and 4 squared is 9/16? Yes or no? Does everybody agree with that? 3 times 3 is 9, 4 times 4 is 16. So did I change the value or just the way it looks? Just the way it looks. All right, what do we do with the power to a power? So it becomes 3/4 to what power? Negative 2. Does that make sense? So x equals what? Negative 2, because the bases are the same and there's exactly 1 on each side. All right, a lot of thought process on that one, and I'm doing it with you so when you get to this on your own, you understand how to do something like this. Questions on number 8. If I gave you this and said just try it on your own, would you have thought all this through on your own, some of you? I hear some no's, I hear some yeses. All right. Now that you've seen it? All right. Number 9. This is the question you guys have been asking me. Let me write it down. 3 to the x times 5 to the x equals 225. You guys have asked, when do we add the exponents? When do we multiply the bases? Because you do not always multiply the bases. Typically, that's hands off. We don't multiply the bases. But that's when the bases are the same. What's the same here? So what do we do with the bases? We multiply. So it's 15 to the x equals 225. A little tricky, but doable. Can I get these to the same base? What's the same base going to be? Good job. 225 is 15 to what power? Second. So what does x equal? X equals 2. What is that?
Or where, like, if it's different,
Thank you.
multiply them together.
Yeah, okay, so when you're multiplying like bases, you only add the exponents, you don't touch the bases. But if you're multiplying and they're different, but the exponents are the same, you multiply the bases. I know that's, I know. All right, number 10, which is why I'm trying to get practice with these. We did it last week, we're doing it again this week, and we will continue to. This is another one that gets students every year. 7 to the 2x minus 3 equals 1. And I want to get them to the same base. How in the world do I get these to the same base? Good job. Anyone else catch that? He said change 1 to 7 to the 0. Oh, do you guys see that? Did anybody else see that besides Zach? Something with the 0? All right, good job. Okay, so now are the bases the same? And there's exactly 1 on each side. Can we drop them? Yes?
Yeah.
So 2x minus 3 equals 0. I'll let you solve, add and divide. What does x equal? 3/2. And you can check it. What's 2 times 3/2? The 2's cross out, so what's 2 times 3/2? Right here. What's 2 times 3/2? 3. And what's 3 minus 3? And what's 7 to the 0? 1. Does it work? All right, last one, number 11. This like save the hardest for the last. This is a difficult one. All right, 3 times 2 raised to the 2x plus gosh darn it, okay, that's a plus, I'll fix it later. 4 to the x equals 1/8. Write it down. I thought I grabbed my whiteout. Tonight's assignment is all. I'm not cutting them in half today. We are doing all. It's not as the 51 or whatever it was last week. It's not that bad. All right. Okay. Do you guys agree it looks a little wonky? All right. First off, any thoughts on the base, the like base to use? What number's throwing it off? Okay, I'm going to cover the 3. What like base would we use? 2. So ignore the one that's throwing things off, and let's get everything else to a base of 2. We'll start with that. 3 times 2 to the 2x plus 4 is what? 2 squared to the x, and 1/8 is 2 to what power? Okay, you guys really want to be paying attention, because remember last week when I showed you that hard one and I said it's going to come up again, not in a true false, and you will need to know how to do it? Here it is again. All right. What does this become? 2 to the 2x, 3 times 2 to the 2x equals 2 to the negative 3. All right, so any thoughts on what to do here? I heard somebody whisper it. Substitution. U equals 2 to the 2x. So I have 3u plus u equals 2 to the negative 3. And I feel like I'm going too fast, so I'll slow down just a smidge, let everybody catch up, put your phones away, because that will not help you on test day. All right, so I changed these two to u, 3u plus u, which gives me what? 4u equals 2 to the negative 3. I'm going to plug it back in. I'm going to do, actually, I won't go so fast. 4 times 2 to the 2x equals 2 to the negative 3. Now the 3 is gone, because 3 plus 1 is 4. And what's nice about the 4? Can I get it down to a base of 2? Yes?
Yeah.
2 squared times 2 to the 2x equals 2 to the negative 3. And I think you guys can handle it from here. So any questions on what I did on any one of these steps before? Well, those of you that are here, what are you going to do with these two? Because I can only get them down to one base on each side. So what am I going to, I can't drop yet.
You do 2 minus 2x?
Right here,
2x minus
2
2.
to the 2 plus 2x equals 2 to the negative 3. Now can you drop? Yes. If you've got it, go ahead and finish it. Does anybody need to explain any one of these steps here? All right, so get your brain to process a problem like this. You see it, oh, everything's good except the 3, cover it, and then you're like, oh, I see the u substitution there. Do your u substitution and continue. What does x finally come out to be? Negative what? 5/2. Now we've done this over and over, and we will continue. This is definitely something you need to know. Questions?